So we're talking about graphs and like mathematical modeling. So we're going to take a look at some of these graphs together on the pages. So again, you can, if I'm writing, okay, I don't know if you have to write necessarily. Let's just think through this. I'm going to write some of it up there. This is 4.3, but to help us, when you're looking at number 2, let's say, okay, number 2, you don't have to write it. I'm just going to draw the sketches like this and then talk about it, okay? So if you write it, great. If you're just following, that's great too. Okay, H and T. So number 2 gives us 4 graphs, right? We have graph A. Actually, that's not H and T. I'm sorry, S and T. S and T. And this is graph A. So number 2 is graph A. Now, it's gonna say which of these graphs would represent the speed of a ball thrown straight up in the air and then caught by the same person. Okay, so you're gonna take a ball, you're gonna throw the ball up in the air, right, and then it's gonna come down, you're gonna catch it. And then it says what graph represents the speed of the ball, okay, and then T would stand for the amount of time, right? So you think about this, okay, so somebody takes a ball, when they go to throw it up in the air, their initial velocity, okay, when you think about it, here they are on the ground, this person is, right? And they're, I don't know what that is. So some sort of neck collar. Okay. Whatever, so the ball, here it is. The ball is going up. Initially, the ball is going fast or slow in comparison to when it gets to the top. What's the ball doing? Fast or slow in comparison to when it gets to the top? Fast, right? So the speed is fast, and then what does the ball do as it goes up? It slows. And once it gets to the top, what's the speed of the ball at the very top? Milo?
Turning downwards.
Yeah, turning downwards. So what's the speed at the very top? 0, right? The ball hits the speed of 0, and then what does it do? Accelerates downwards. It's like when we shot the rocket off a few weeks ago with Johnny. I think I told you that, shooting rockets. But the parachute didn't pop. And so it went up, it hit 0, and then it came down like a rocket and pierced the ground, bent the rocket in half. So same with the ball, right? You don't want to be underneath that ball, do you, when it comes down? You want to catch it for sure. I had a friend in college, Stephen Bass, super smart kid. But he's like, here, let me show you something. Takes a full can of Pepsi. I'm like, okay, and then he just headbutts it. Explodes. And I'm like, what? Smart kid though. Then he's like, here, come with me. So I'm like, okay. So we go outside, then he takes another full can of Pepsi, throws it up in the air, as he can. And I'm watching it, and then he like runs underneath it and then headbutts the full can of Pepsi. And the whole thing just explodes. I was like, how did you discover this? It was his special trick in life. So he would just explode cans of Pepsi off his head. So I don't know where he is today, and you kids find out. Anyways, yeah, it might be. So we look at this. So the speed here is really high, and then it gets slower and slower, and then the speed is 0, and then the speed goes faster and faster, right? The ball increases due to what? Gravity. Yeah, nice. And it pulls it down, and then you catch it way down here. What's the speed when you catch it? Way down here, speed would be 0 once you catch it. Okay, so if we look at graph A, what this represents is the speed is really what? High, and then the speed goes low, and then the speed, right, is what here? What's the speed right here? 0. And then the speed, because we're just looking vertically, the speed is slow, increasing until it gets right down to the end. Now, actually, when you hit it and catch it, then the speed would be 0 right at that moment. Okay, so then in a matter of time. So then here, if you think about the next graph, what do they have? The next graph says, this is for part B, speed is 0, and then the speed is getting faster and faster and faster and faster till it reaches the peak, and then it gets slower and slower and slower. Is that true of a gravitation when you throw the ball up in the air? No, what is the ball doing? The ball is slowing. So the ball is not getting faster and faster and faster, right? So B graph, we're going to say no. A graph is a potential. This one states here to here. This is for graph C, right? And this states the ball is very fast in the beginning. As soon as it leaves the hand, the ball is fast. But then what does it do? It just decelerates until the speed is what? 0. But the issue is the question states, represents a ball thrown in the air and then coming back down. Again, what do we know? Once the speed hits 0 at the top, what does it do? It accelerates due to gravity, right? So does this show, a decrease in speed, but does it show an increase as it comes back down to you? No. So C, we're going to say no. And then the last one is graph D, which just goes like this, which means the speed is 0 and then it just keeps getting faster and just keeps going. No, right? So which graph is it going to be? A. There you go. Okay, so now some of these, like that one's, a little fairly straightforward. Some of these might be a little bit more difficult to look through and to analyze. And that's okay. You can work through that. Let's take a look at number 4. Number 4 though says you're not picking a graph. It just says interpret the graph explaining each labeled section. So if you look at number 4.
I'm sorry, may I take Nora?
Oh, thank you.
Thank you. I know, she's such a gift.
What did she say?
Handful.
Is that what she said?
Yeah.
Little does she know.
Yeah.
So, there we go. Number 4, take a look at that. This is at 12 a.m. and then it proceeds to, they have this section A and then section B like this and then a little thing here and then C and then there and then there's like D and then they have 12 a.m. out here. Okay, and then they have this graph and it floats down to like A, then it jets back up here, and then over B, and then something like that. I can't draw the graph perfect. Something like that. Okay, so it says cars passing through an intersection, number of cars, and then this is the time listed like that. Okay, so we have our graph here, and we're trying to analyze what is this graph referring to. Okay, so some of this is like you have to think through the interpretation of it, and you can look at the back of the book and see what they're looking for. So what this represents is the number of cars. So if you look at the number of cars at 12 a.m., are there a lot of cars at 12 a.m. in comparison to the whole graph, right? At 12 a.m., are there a lot of cars?
No.
No. And so at 12 a.m., notice then the decreases, right? Decreases through the time slot, okay? And then at whatever this is, they don't give a time, right? But some sort of dash here. What starts to happen? The increase of cars, right? Anybody travel from the Bitterroot? Okay. Does it matter when you leave to come to school? You bet. Why does it matter? Because of traffic. Is there a nice sweet spot where you can avoid mass amounts of traffic? Yeah, and if you miss that sweet spot, is there a lot of traffic for at least a window of time? You bet, right? So if you think about that, it's like, okay, as it starts to build, as people start commuting, right, you get into this rush hour traffic, if you will. And then you get into maybe throughout the day it decreases, and maybe at rush hour it increases, and then what happens? As it gets into the evening hours, it decreases, right? So that's what it's representing. It's some sort of, you could say, it says interpret, right? Interpret each graph explaining each labeled section. So you could say A, early morning hours, very limited traffic. B would be the start of what we would call rush hour, right? Rush hour would be B. Maybe C, I didn't do the graph perfectly. Yeah, that's okay. There's a little bit of a bump in C. What that might that be? That could be some sort of like increase in the middle of the day, lunchtime. Maybe there's like some sort of lunch hour traffic. People are going out and about. And then this would be an increase at rush hour going home from work, and then a decrease in the early morning hours. So that's how you could interpret that and say, hey, A represents like early morning hours, no traffic. B is rush hour. C is a lunchtime. D is back to rush hour going home. And then people aren't driving after D. Okay? So that is what you want to do on some of those, is to just analyze and do something, write some sort of analysis and interpretation of that. Okay, then we go to page 174. Go over to page 174, and we are going to go ahead. Now you can actually do something on 174. Let's take a look at number 8. So you can do this really quick here. It says sketch a graph without numbered axes, illustrating each of the following situations. So when they say without numbered axes, what they're saying is you're not going to write like 10 hours or 10 minutes or a speed of 40 miles an hour or whatever. Okay, you're just going to write a graph that represents something that's going on. So like this would be a graph without a numbered axes, it's just a speed and a time, right? So go ahead, look at number 8. We'll look at it together. It says Larry's distance from home as he drives to the grocery store, shops for half an hour, and then returns home. So we're going to write a graph, or draw a graph, talking about Larry's distance. So I'll give you a little help here. The y-axis will be the distance, okay, from his home. So distance from home, maybe give it a little more direction. Distance from home, and then some amount of, this will be our time going, okay? So let's go ahead and draw some sort of graph that represents his distance from home. And when it says his distance from home as he drives to the grocery store, shops for half an hour, and then returns home. So where might we start in terms of his distance from home? That's our y-axis, and our starting time. It's like you have a stopwatch, right? His starting point would be what?
0.
0, yeah. So should we start him up here that he's 10 miles from home when he's leaving from home? No, we start him at 0, and then he's driving a distance. Now, our distance is going to change, right? So if you draw a line like this, does that make any sense? Time is going, correct, but what about his distance? No. Now, you could say, well, what happens if there's traffic? And he would slow down. We're not actually getting into the weeds of that. We're just saying his distance is going to go up or down as he leaves to go to the store. It's going to go up. But if you go like this, straight up, then that represents that no time has passed. He's in this like weird, sci-fi. Time has an ellipse, but he's headed to the store. Okay, so time is going, distance is increasing, therefore something that looks like this. It doesn't have to be a perfect analysis. It's like, there he goes. He's increasing his distance from home, and the time is going. He gets to the store. Does his distance increase anymore? No. But does the time continue? Yes. So what would happen to our graph right here?
Right.
Well,
Like straight to the right.
yeah, a line is straight, so.
Horizontal line.
There you go. Yes, good analysis. Horizontal line for some amount of time. Do we know? It says a half an hour, but do we need to analyze it and say perfectly what is that in relationship? We have no idea because we don't know how long it took him. He just is at the store for a half an hour, and then what does he do? He drives back home, and so what do we do here? It goes up or down? Down like that. There we go. Now, if you were to draw that graph on a test and you went like this and then like this, I'd say, nah, he was in the store for some amount of time, represent that, right? So give it some sort of obvious representation. The distance didn't change. This, you're like, no, look, it's tiny. It's, it's like, okay, not helpful. Make sense? So do something that's like somewhat obvious on that one, on ones like that. Okay, so that is what you're working on for those ones. If you go to page, same page, 174, and then you take a look at number 14. Use the table on the right for exercises 13 through 16, okay? So in that, you don't need to draw all of this out, or write all this, but let's take a look at number 14, but we got to look at the table that they give you. And if you look at the table, this is for 13 through 16, but the table offers you this information of income and then offering. Okay. So an offering, what are they talking about? What's an offering? Anybody heard of the word offering?
Tithing?
Tithing, yeah, they're talking about like at your church, right? So the idea is that what's the general rule, biblical model of what percent of your income you're supposed to
10%.
give back? It's what?
10.
10%. That stems from, right, if you read the Bible, there's verses in there talking about giving a tenth of all of your first fruits to the Lord, you know? And so that's where we get the 10% model. Okay, so 10%, look it up in the Bible, and typically people assign that to, usually assign it to the church that they're attending. Sometimes they assign it to giving, giving to people, whatever. Okay, so 10%. So what we see here is that they have a $50, and then what's the offering? 5, and then the next one's 100, and what's the next one? 10, and then so on and so forth, right? So if you look at this, it says, like on number 14, describe the general trend of the data. The general trend, anybody want to describe what's the trend?
10%.
10%. Yeah, you could say you're giving 10%. You can analyze it specifically. Another thing you could say is, as your income increases, what happens to your offering? Your offering increases. That's also a trend that you could recognize. Or specifically, you're giving 10%. So that's all like number 14 is asking, just describing what you see in the data. Now from there, it says like on 16, it says what? Use your graph, although we didn't make a graph yet, but you could. Maybe we should talk about making a graph on the, sorry I'm jumping around, but like number 13 says make a graph. When you go to make a graph of like income of 50, you probably don't want to make 50 like this, do you?
No.
No. So you're starting at 50. What's the last one they give you on there? 1,000, right? If you're looking at that. So how do you represent so that you don't have to do all these? You could just say this is 50, and do you really want to go 100? And then 150, and then to do all the way up to 1,000. No, but you could just give an estimate, like 50 is 5, 1,000, what are we gonna get up to? Like 100 is like this. And so you could just make an estimate of some sort of graph, like this, and then 100 is 10, and 150 is 15, and then make some sort of estimate like that. So when you make the graph, that's what it would look like, okay? I'm not going to get too worried about the details of that. Okay. The other thing, so that works for that. But then it says use your graph to determine her income if she gave an offering of $12.50. So it's like thinking about the chart here. The offering she gave was $12.50. The question is, what was her income if she gave $12.50? And you could look at the graph and also analyze what's going on. And in this case, you would maybe go back and be able to state what would her income be if she gave, I'm saying she, yes, there's a her in there, Mariah's income. What would her offering, what would her income be based off of the $12.50 offering?
125.
125, yeah. Now that would come from the fact that we kind of understand the 10% idea. Also, you could look at the graph and say, okay, if she's giving, $12.50, where would that fall? If this is $15 and $10, halfway between 100 and 150 is going to be 125 because 12.50 is halfway between 15 and 10. And so you could analyze it that way. Okay? So that's what you would do on some of those. This one is very specific because you could do the 10% rule. You get to ones like 17 through 20. That one is actually, you're just going to make an approximation. On 17 through 20, you're going to have to approximate because it's not an exact like 10% like we were looking at with the income and offering. So some of those ones you'll have to just make an estimate on. Okay. Let's pause there for now, and I think you get the general idea. We can keep throwing some charts up there and graphs up there, but I think you get the general idea of what to do on looking at these models. So we're going to pause there. You're going to get started on 4.3 here. We will plan on having to do tomorrow is fine. I think that should work fine on that. Okay. Yes.
I hope Isaiah.
Yeah, he's got some stuff. Isaiah, do you have some stuff? Zach says he has everything that he can grade. Or